Okay, so I acted immaturely, and I apologize to the people that I personally insulted. I shouldn't have done that. I should have stuck to speaking about the facts related to emulation. Um, Basically, it just pushes my buttons when people take a heaping shit on arcade games. But in the spirit of actually explaining things calmly and rationally, let me talk a little bit about why you need a really fast CPU to do emulation right. So this is the MAME, INI file for Groovy MAME, and Groovy MAME has a feature called frame delay. And a lot of people don't know what frame delay is, so I'll explain it. So when you're emulating something, everything has to happen, within, each loop, that you're running through, when you're emulating a program. So basically, when you're emulating something, for every cycle of that emulation, you have so much time to do all of the work and then present the sound and the graphics and everything, so people can see and hear it. Basically, you have so much time to, output, whatever the emulated machine is going to do. So, for example, let's say you're running at 60 frames a second. That means that for every frame you have 16.7 milliseconds to emulate all of the hardware and push that stuff out. Now, here's the thing, though. There's actually different times when inputs get pulled. So as I'm like right now, typing numbers in on this keyboard, Windows is constantly pulling, checking for changes, checking for inputs, and in fact, if you actually measure it, Windows has pretty good response time, really. It takes about 2 milliseconds. That's about how much input latency is on like the average, key press, if you ignore all of the other garbage that gets involved, with Windows, other APIs, other, bull crap that they layer on top of the actual operating system. So basically, you got about 2 milliseconds there, for your inputs to register. Now, here's the thing, though. 2 milliseconds is less than 16.7 milliseconds. Now, what happens if I'm emulating a game and I happen to press something right in between those 2 millisecond intervals, and the emulated frame that comes out isn't actually the very last thing that I pressed. That's basically input delay. So let's actually just like map this out. So let me just kind of write this so we can think about it. So basically, here's frame number 1 of a Neo Geo game. So frame number 1 happens, and let's say that I have 16.7 milliseconds to display the next frame. Okay, so and we're pulling at about 2 milliseconds. So let's just say that right after frame 1, right after it happens, I get some pulling and whatever. As soon as MAME or whatever emulator moves on to the next frame, it is going to immediately process everything. It's going to basically do the emulation job. And so this is going to involve emulating the CPUs, pulling for inputs on its own, and although ideally it should happen in this order, and then it's going to present the final frame to your GPU driver and then your GPU is going to schedule that to display. So, but here's the thing, though. All of this happens And it doesn't necessarily happen, where your final input pressed is actually the last thing that it got here before, it did all of this work and actually presented the frame. So here's what frame delay does. Frame delay, is a 0 through 9 setting, and the numbers represent, a percentage of the emulated frame. So a frame delay of 1, is actually, or actually, I'm sorry, it represents 10% of the emulated frame. So a frame delay of 1 delays the processing of the emulation, by 10% basically, and we go on until we delay it, by 90%. I mean, of course, we can't delay it 100% because then you would never even render anything. And so basically, what this means is, if I have no frame delay, it means that I have 16.7 milliseconds to do everything, to do all the work that's involved in emulating the game. However, if I delay the frame by 90%, it basically means that I only have a few milliseconds to do all of the emulation work before I actually have to present the output to the GPU driver, which is going to then actually render this stuff. So think about that. Think about how much it increases the CPU requirements. You can have the simplest game, the most basic game, but when you are delaying the processing of the emulation by 90%, you're effectively doubling how much it costs to emulate that. You're basically saying that it takes twice as long to emulate this hardware almost. It's not quite twice as long, but it's almost that much. And so that is why this is so important. So let's think about what this is actually doing. So if we wait until the very last second, if we wait 90% into the 16.7 millisecond window that we have, to actually to pull for inputs, it means that we're pulling for the input that you pressed, the button that you pressed, the joystick that you moved at the very last second before we emulated the hardware. So it means that when we emulate the hardware, we have the very latest information. We have the very latest state of the inputs that you pressed, so that what we can send to the emulation job is the very latest thing that you did. This minimizes input lag, because typically what's going to happen here is you're going to pull for inputs at the very beginning of this 16.7 millisecond window. And like I said, you have 16.7 milliseconds where other things could have been happening. Remember, Windows basically is constantly pulling. It's getting new inputs, every 2 milliseconds. Something could have changed. So it's possible that it was bad information. I could have pressed up and then pressed down, and because that 2 millisecond window got missed, it actually took the wrong input. The wrong input went in to this machine, this emulated, this emulation job, and it actually ended up presenting the wrong, result. So basically, that's what's going on here. I mean, of course, like I said, I mean, we're getting to the point where the average person might not even understand this stuff. But this is what it really means to have the best possible setup. You effectively have to take whatever the requirements are to emulate a game and double them to talk about how much performance is going to be required with frame delay 9. And that's what you actually want. Now I'm going to actually demo this. Here's the Groovy MAME setup. I'm putting on frame delay 9, and I'm going to run death smiles. Full disclosure here, I have a 4.2 gigahertz i7 CPU. It's pretty fast CPU. I'm going to run Groovy MAME here and run death smiles. And I want you to look at the frame rate I'm getting here. Oh, I'm not getting 100%. Oh, look, it's going a little bit lower. I'm getting 99%, I'm getting 97. 97. It's not, I can't even fucking max out death smiles on an i7. This is death smiles. This isn't even one of the more expensive games in MAME. It's not as bad as like later 3DFX Voodoo based hardware or faster more demanding games. I can't even get full speed with frame delay 9 on this setup. And you're going to find that if you use like a really old, look at this, I'm dropping frames. And you're going to find that if you use like an older, crappier CPU, you're not going to be able to get close to this. Now, yeah, you see this? I mean, look at it. I'm dropping frames. I can't even get 100% speed. And this is why I say that it is an absolute farce when people say you don't need a powerful CPU. An i7 4.2 gigahertz CPU is not fast enough to completely max this thing out, 100% of the time. So think about that for a second. So think about what's involved there, and think about how this thing actually works. You think about what's actually happening. Once again, these are the steps. We pull for inputs. We do the emulation tasks using the last input that we pulled. We present the the results to the GPU driver, and we get output. This is what's happening. This is what's actually happening when you're emulating something. So pulling for inputs is something that you want to do as late as you possibly can, and that's what frame delay allows you to do. It allows you to delay pulling the inputs until the very last possible moment, so that what we send to the emulation job is the very latest thing that you pressed, because pulling for inputs is faster than an emulated frame. An emulated frame is only going to be like like I said, 16.7 milliseconds. Games typically tend to run from like 50 hertz to 61 hertz roughly. So you're talking roughly around 16 milliseconds. Windows pulls much faster than that. This is how you minimize input lag. This is how you get the very best result. And I'm telling you, you think that I'm just bullshitting? You think that this is just, masturbatory stuff and doesn't really make a difference? It makes a difference. It is noticeably more responsive when you play something with frame delay 9. It's actually pretty crazy. And what I've noticed is if you use a variable refresh display, you also get pretty damn good results because you're not waiting for VSync. And because you're not waiting for VSync, essentially, you're just blasting that thing as fast as you possibly can. So effectively, you are like pulling for input. Like say you have like a 144 hertz monitor. Even if the game runs at 60 hertz, you're effectively pulling at like 144 hertz. It's really good. Okay, so this is what I'm talking about. This is the kind of thing. I mean, like I said, I could write a novel about this stuff. There is so much going on with emulation. There's a lot to it, and this is why I get so frustrated, because people don't even know. They're not even aware of these issues. They don't even. Really, you could give them seconds of input lag, and they wouldn't even notice it. You saw the video. They just randomly bash on other people's joysticks. They don't care about precision or responsiveness or quality. They don't even notice. They didn't even play the games when they were originally in the arcades. They don't even know how responsive they're supposed to be. And if you play new video games, they're all incredibly laggy. Like the average Xbox game has 30 milliseconds or around roughly 2 frames of input lag. They really, like the average young kid doesn't even know what responsive gaming feels like. It's pure ignorance. So this is what I'm talking about. This is a little taste. I'll do some more videos and actually talk about what's going on. But this is it. This is the nitty-gritty. This is what's going on.